Welcome to IFR6000 operator training. The currently released software for the IFR6000 is 3.15 for ModStrike 2 units and 4.15 for ModStrike 3 and above. The current revision for the IFR6000 operations manual is issue 15. Included in the transit case are the IFR6000 flat plate antenna, antenna shield, charger power supply, RS-232 USB bridge, 6-foot cable, and 1-foot cable. Directional antenna. Optional accessories consist of the UC584 coupler, which can be used to eliminate problems with over-the-air testing. We have single and dual versions of this particular kit. Desktop stand, tripod dolly, and then various lengths of coax for testing large aircraft. The RS-232 bridge is used to connect to the IFR6000 to a PC and allow downloading of test results as well as updating firmware through the USB port. Carefully connect the breakout box to the IFR6000 as the connector is easily damaged by misalignment. The IFR6000 is well suited for over-the-air testing. However, it does present some problems when testing near high traffic airports and so on. The FAA has issued a SAFO 17002, which specifically addresses the problems with over-the-air testing. When you perform over-the-air testing, certain configurations of your aircraft could appear as if it were actually flying in close proximity to other aircraft, creating TCAS alerts. To mitigate this, you can use the UC584 in place of the over-the-air testing, and this will directly connect the IFR6000 to the antenna of the aircraft that you're actually testing. Use the antenna shield for diversity aircraft that have two antennas and place the shield on the antenna that's not being tested. Controls on the front of the IFR6000. Power button, this turns the unit to the on condition. Charge indicator illuminates to show battery charge status. Yellow is charging, flashing. Yellow is faulty battery, green is fully charged. Interrogation shows when the IFR6000 is actually interrogating a transponder. Reply shows when the transponder being tested actually provides a reply. The navigation buttons will allow you to move around inside of the entries in the menus of the IFR6000. Self-test is performed on power up. The self-test screen is displayed in this slide and shows the status of all the modules and specific parts inside of the IFR6000 that are being tested. As you can see here, we have a battery back ram failure, and it is recommended that if you have a fail in the self-test, then please contact our customer service department to arrange for service of your unit. To power up the IFR6000, press the power key to power the test set on. Press Setup Control key to display setup screens. Continue pressing Setup to cycle through the various setup pages pertaining to individual instruments. When testing your aircraft, the aircraft must be in a specific state for testing. For example, in the transponder auto test, the transponder must indicate that it is in the airborne condition. The GPS receiver must have a lock on the GPS location, and the transponder must be in the transmit or not in the standby position in order to do your testing. The IFR6000 starts up in the transponder auto test screen. The transponder auto test consists of 19 tests to check the performance of the transponder being tested. Before starting the test, the transponder should be in the airborne condition. The GPS receiver should have a valid fix, and the transponder should not be in the standby position. It should be in the out position. The operator must choose the transponder configuration that he is going to be testing. Most generally nowadays, the testing performed will be on a Mode S Class A transponder. If you press the info button, then it will tell you what the pass or fail criteria for the power, frequency, and sensitivity are. By accessing the setup menu for the transponder auto test, the operator can choose the antenna to be tested, range to the antennas, cable loss, antenna gain, UUT address, diversity on-off, power limits, and transponder capability. When configuring the distance for the test, the actual distances from the flat plate antenna to the actual transponder antenna should be listed. If the operator chooses to use an UC584 coupler, simply slip the coupler over the top of the antenna, press it firmly against the fuselage, and then toggle the locking lever to the locked position. Connect the coupler to the IFR6000 and then configure the setup menu in order to select the method of testing to be direct with coupler. By setting the UUT address to auto, the 6000 interrogates the aircraft with a Mode S all call to get the announced address. By setting the UUT address to manual and entering the Mode S address of the aircraft being tested, the 6000 will report the Mode S address. UF11 is an uplink format Mode S interrogation to request information. Information is reported via a downlink 11 or a DF16. Once the IFR 6000 is configured for setup, then the operator would return to the transponder auto test screen. Auto test consists of 19 different tests to check the performance of the transponder being tested. Upon completion, the IFR 6000 will display the most important information on the auto test summary screen. In the upper mid part of the screen will have a pass, a fail, or no reply. Pass will show that all parameters in the 19 tests pass the specifications. Fail shows that there has been a failure indicated in one of the tests that are in the auto test. No reply means that the aircraft didn't reply to the interrogations. Most notable on the auto test screen is DF17 detected. If it has a yes, then the transponder is ADS-B equipped and it is transmitting ADS-B squitters. If it's indicating no, one of two things can happen. The transponder being tested is either not ADS-B compliant or the aircraft is not squittering the ADS-B squitters because it doesn't have a GPS fix or the aircraft is in the surface position instead of airborne. Many customers have the question, why does my power and frequency occasionally fail? The transponder system on an aircraft does have a L-band antenna that is connected to the fuselage. The gain on the antenna or loss is specific to the antenna that is installed. In various positions of testing, you can either have a gain or a loss on this particular antenna pattern. So your position during the testing does influence the power and frequency. Over-the-air testing can be influenced by the hangar, other aircraft, toolboxes, vehicles, anything metallic, even being bounced off the floor of the hangar can influence your testing. So position of the items that I've described should be as far away from the aircraft as possible. Most effective testing is performed out on the ramp away from other aircraft or metallic objects. Thank you for watching this video, and if you have any questions, please contact me at the email address listed below technical support.